Alright, so now that we have an idea that this Pinacol rearrangement will definitely lead you to your product that you want to form. And for that matter, generally, Pinacol rearrangement reactions are only favored by the symmetric diols, that is, the compounds that are having their OH groups. Then you have a plane of symmetry across them, everything is the same. Then it means you are going to form only one product, right? And also, we've learned that semi-pinnacle rearrangement is also regioselective. I mean, it uses its regiochemistry in the determination of the product that you should be expecting. Now, we also found out that there is a problem with the pinnacle rearrangements when it comes to unsymmetrical diols, where you don't know which of the OH groups to actually protonate and leave as a good living group, because the moment you protonate an OH group that's not supposed to be protonated, then you are going to get a different compound. To eliminate all these problems, then we are having the semi-pinnacle rearrangement. This semi-pinnacle rearrangement is very simple. One of the OH groups has been replaced with X, where this X is actually a good living group. It can be our OTFs, our OMEs, it can be a halogen like bromine, chlorine, iodine, fluorine, and all those things, right? So now let's try and look at the mechanism. There are four main types of reaction mechanism under the semi-pinnacle rearrangement. So now the first thing that we are going to look at, I will call it epoxide formation and opening, right? You form an epoxide and also you open the epoxide. By doing so, we are removing this X, because if you look at the starting material, there is no X here. We remove this X, generated our carbocation, we did a migration, and now we are forming our thermodynamic product, right? So now let's start. I'm going to draw my same starting material here, right? Drawing my same starting material. I'm having my OH. On this side, I'm having my R2. So look at the regioselectivity of everything that I'm doing. Okay, so that everything will be simple. Just look at it very carefully. How this was my X, and now this is my R3. Now in the presence of a base, right? Here we are using a base. The reason why we are actually using a base is to remove this particular hydrogen. When we remove the hydrogen, it forms an alkoxide, right? So let me try and put my oxygen here. Now let me change this thing to oxygen bonded to a hydrogen. Okay, because we are using base, in the presence of our base, try and deepen it so that you know that this one's an oxygen. In the presence of our base, right, this base is going to remove this hydrogen by deprotonating it, and now the bonding electrons will fall onto this oxygen. Okay, and now you are going to form, let me put the mechanism here. So we are doing mechanism. Right, so from there I'm going to form an alkoxide. So my there's an R1 here, so R1, then I'm going to have O minus, and I'm going to have my R2. Right, this is my R2. Then on this side I'm going to have my X, which is a good living group, and I'm going to have my R4, and here R3. Alright, so here you are going to form your epoxide. Remember, this one is partially negative and this one is partially positive. If you understand this, then that's how you know your formation of your epoxide is possible. It will attack this, right? When it attacks it, then you are going to have your good living group escaping. So with this, we can move on to the next step. Here we are forming our epoxide. So now we are going to have our R2 will be here, right? We are also going to form something like this, and we are going to have, so this is the carbon, we are having our R1. Okay, R1 is kind of solid wedge. And then let me just move to the other one, the other carbon. Okay, and now let me also put my R4 here. R4. And then let me put my R3 here. So now I'm going to form my epoxide. Okay, now this epoxide I'm going to form, I'm going to have this particular oxygen in the middle acting as a bridge. So epoxide, now this is the epoxide that I'm having with the lone pairs here. Okay, so with this epoxide, now I can do the next thing. So if you are doing or if you are following our radioselectivity, right, and also radiochemistry reactions, then you know that epoxide, they tend to hold it in the solid wedge position, right? Either they are all holding the solid wedge or they are all holding it backwards. So I can redraw it as my R2 bonded to this side. I can also have my R1 or attached to this carbon, having my R4, and on this side I'm having R3, right? And they are all holding the epoxide. This is what I mean. And you're having your oxygen. It's still the same thing, right? It's still the same thing. Now, the next you are supposed to do is you are going to open the epoxide. So now the next thing that you are going to do as the epoxide, because you generate a carbocation here, opening the epoxide, right? We'll now have our electrons back, and we are going to form our epoxide again. We are going to form our alkoxide. So here we had an alkoxide, and now we did epoxidation and also removal of the epoxide, right? We did that just to remove the X because it's a good leaving group. Now, the moment to remove the X, you are going to have a reaction with a carbocation, and then we can do our shift from there. So now let's try and move. Now we are going to have our alkoxide here. We are also going to have our R2 back, and then on our solid wedge we are going to have R1, all bonded to a carbon. Now this carbon will now be having the sp3 because it's only bonded to R4 and R5, and there is nothing there. So our carbocation, positive charge. And if you look at the product of it, right, it means we did something there, we removed something. Okay, so this is that here we are actually trying to remove, or we are trying to shift something around. Now this H can also be the same thing as our R1, so let's replace it with R1 from this side, because generally when you start solving questions and I replace these R groups with the atoms itself, you are going to realize that one of it can be a hydrogen, so that we form our aldehyde, right? So with the same thing we can move on, and then because we are forming our carbocation and we are moving our R2, right? In this particular reaction, look at our product. Our product led us to the formation of R1 being on this side, so we moved R2 in a migration or a shift. So we are going to move the R2 here. If it is hydrogen, it is a hydride shift. If it is an alkyl group 2, it becomes an alkyl shift, right? And now we are going to generate our carbocation, but all these things happen at a go. This alkoxide forms back our ketone, because you know that in a Pinacol rearrangement we form a ketone, so it comes here to give you a double bond, and now one of the bonds should be broken, or else carbon will be forming 5 bonds. So that's how come we are having R2 moving on to this side. The R2 will not move by its own unless something is pushing it. So this alkoxide will form our ketone product back, or our ketone functional group, and then it will force one of these groups to move on to the carbocation. So now you are going to have our ketone, and then we are having our R1, and on this side, this particular carbon, we are going to have our R4, we are going to have our R2, and we are also going to have our R3. So this is the whole mechanism. This is a reaction type 1, converting this particular substrate or this particular starting material onto this product. This is the mechanism that follows. You first need, in the presence of your base, it will deprotonate our OH group, form an alkoxide. Now this alkoxide will fall in back to give you an epoxide. Then formation of the epoxide will make sure that you are having your good leaving group leaving the intermediate species. Then you are going to have your epoxide opening back again. So this is the epoxide, it will open back again, and now it will generate your carbocation. Now you have to generate your carbocation, form your most stable carbocation. So we removed one of these particular R groups onto this carbocation, right? By doing so, we know that if your oxygen bearing the negative charge is here, it will definitely form our ketone product, right? So it will fall back to give you your double bond carbon and oxygen. Carbon cannot form 5 bonds. One of the bonds is needed to move. That's how come you're having your R2 moving onto where the carbocation is, and then you're having this particular reaction occurring. So that will bring us to the end of the formation of this particular epoxide, right? And also bring us to the end of the reaction type 1. So the next thing that we'll be doing, we are going to take real life examples where these R groups are actually methyl groups, or let's say alkyl groups, and now we start solving the questions accordingly. So let's go on to the reaction 2 or type 2 reaction.